With the snow, honestly, I'm a little bit like slower today. Okay.
Snow stresses me out.
I was already stressed out, so it's not a good combination.
Yeah, I went in the ditch twice on the way to school today.
You did?
Oh. Like 3
My
times.
parents wouldn't even let me
I
drive.
went on
but
the
I'm just
corner
saying
like
you're
5
right.
miles per hour, and it was like,
It's a
Why
bad
should you
driver.
drive?
Because I'm going to
Did
Bozeman
you get out
next year,
yourself?
so I need to know how to drive
Did
because
you
they
get
get
out
worse
yourself?
snow.
Yeah, I was able to like, the backwoods started.
All right, are you guys ready to find out what implicit differentiation is?
Why do you just turn like normal?
I did. I did like 5 miles per hour.
It's not as scary as it sounds. Okay,
3 miles per hour.
You just said 5.
5, 3, same thing. You guys are stupid.
okay.
Muy estúpido.
So we have, so far we've been taking the derivative of explicit functions. This is an example of an explicit function, which means y is explicitly, like, it's all by itself, okay? So explicit functions,
Is when y is with other things?
explicit would be when y is all by itself.
Oh, the other one,
Implicit,
sorry.
implicit is going to be something like,
I feel like it's going to be way worse. Because I feel like you have to get y by itself and then
something like that, right?
Why?
Is y by itself?
No.
I mean, could we get y by itself?
Yeah.
But do you want to take the derivative of what that is when y is by itself?
No.
No, it's awful, right? So there's other ones like,
It wouldn't be that bad.
Why don't they just solve it for us and put
It'd be
y
like
on the
6
same
month
side?
sides.
There
Y
you
equals
go.
6 month sides.
Whoever made math is stupid.
so like something like this,
Question. Oh, is that just a new equation?
can y be by itself? Like, could you solve that for y?
And if you like take a y out, like
Of those
I mean,
two,
some-
like you can maybe get these
Stop.
over
No,
and then
no,
take a
you
y
can't.
out, but then you
No.
still have a y inside.
Someone could probably figure it out, but
Would you want to?
No.
Would you really want to differentiate it after you did that?
No.
So there's this thing called implicit differentiation. So when we have a function that's not explicit, where y is not all by itself, we can do this thing called implicit differentiation. So here's my next question for you. F of x equals y. Do you agree with me there?
Okay.
Right.
Right, like we've talked about this, f of x and y are the same thing, right?
Yes.
Okay, f of x means y, y means f of x. So y is a function of what?
F of x.
Y is a function of x, right?
Mm-hmm.
Y is just some function of x. So if I said like y equals x squared plus 2, y is a function of x, right? This is a function. Okay. So with the chain rule, when we talked about a function, we have a function of x, and we take the derivative of a function of x inside of another function. Do you remember with the chain rule that we like take the derivative of the outside function, and then we tack on the derivative of the inside function?
Yeah.
Okay. So, here's my question. What would the derivative of y with respect to x of y squared be? What would it be, do you think?
The square root of x.
2y.
Okay. That's the derivative of this outside function. What if, okay, so what if y equals x squared plus 2? So then y squared is really
So it's
x squared plus 2 squared. So see, it's a function of
so
x
you'd have
inside of another function.
Yeah.
So we would take the derivative of this,
Okay.
and we'd
Yeah.
multiply it by the derivative of the outside function,
So it'd be 2 parentheses y.
times the derivative of the inside function,
Times y prime.
times the derivative of the inside function.
Okay, yeah.
So I take the derivative of the outside function, which is like whatever, like 2y, right? The
Yeah.
derivative of y squared would be 2y. But since this is actually a function inside of a function, there's a function in that y, you always tack on y prime
Okay.
With the chain rule.
because of the chain rule. Okay? So anytime I'm trying to take the derivative of a y, I take the derivative of it like
And then you just
of the
tack on
outside
y
function,
prime.
and then I just tack on y prime or dy dx.
Oh, that's not bad at all.
It's not bad, right?
Oh.
So if I had like,
Simplify.
So it has 18 numbers in it,
And then you gotta simplify, do algebra, and it's like, well, hey.
See, look at
okay,
the warm-up
so
problem.
with the derivative of 2y to the fourth, remember y is a function of x, right? So we take the derivative of the outside function,
8
y to the
8y
third
to the y prime. Oh, 8y.
times y prime times y prime. Or, I'll probably write it like this a lot of times because it's just easier to see. Okay, so anytime I take the derivative of a y with respect to x, I use the chain rule and I tack on my y prime. Does that feel okay?
Yeah.
Okay, so
Ugh.
on the warm-up problems,
You still don't.
well, these ones are easy. Y equals x, what's the derivative of that?
Why?
dy dx equals 1, that's easy, okay. Y to x squared is,
Correct.
Oh, what's going on?
we're just doing these warm-up problems that are actually like
Okay.
before what I just talked about, okay. So then, this one, dy dx is a number 3.
4 times 2x.
We bring the 2 down, and we leave the peanut intact. And then we multiply, then we multiply it by 2, so you're right, 4 times 2x minus 1.
Yeah, but those are just regular chain rules.
That's just regular old chain rule, but look, see I took the derivative of y,
Number 5.
and so then number 4,
Number 4 still is bad.
it's just what we talked about. Okay, number 5, x equals y squared.
2y
2y prime.
times y prime.
Mm-hmm.
Why did they all be this simple?
And then what's the, if I took the derivative of this side, I also have to take the derivative of both sides, right?
So it'd be 1.
It would be 1. So what is actually dy dx? What is my actual derivative?
1/2.
Y prime.
1.
1/2 y.
See how this is, yeah, see this isn't by itself? So what if I just divide both sides by 2y to get my dy dx by itself? So my actual derivative, dy dx, 1 over 2y.
1.
Yeah.
Yeah?
Okay.
So this makes sense, right? That we
Yeah.
to this.
I just
But then if we want to find, I mean, then that's not really our derivative, right? Because this is,
don't.
our derivative is dy dx, right? That's what our actual one, or y prime, and so we just want to get it by itself. So let's take a look at some of the
It's a beard and a top.
hard examples. So those ones were the easy stuff, right?
Yeah.
Okay, what happens when I have something, yeah, I think I actually have this
Other
already
people
written, so.
thought it was in that too.
Oh, okay, actually, let's go back. So,
Oh, it does look like an
explicit, implicit, we got that. Okay, here are, what is that supposed to be?
It's supposed to be a beard and a top hat.
Oh, it looks like a knife. I thought this all yesterday as I was sitting here staring at that while I was doing my work. I thought it was a knife. I thought it was like a killer
A knife got
T-Rex.
stabbed.
It's just
Yeah.
holding a knife in this.
Okay.
T-Rex wanted to be able to kill people with his tail, so it's put a knife through his
It
face.
stabbed itself.
So
in the-
basically, our procedure when we're doing implicit differentiation, we differentiate both sides of the equation, right, with respect to x, just like we always have. But anytime you differentiate y, you just tack on that y prime because of the chain rule. Okay. Then we try to get dy dx all by itself on one side. That's it. That's what all of those long explanations say.
Oh.
So let's try this one. So let's take the derivative of both sides. So we have 2x minus, and then we bring the 3 down, so we get 6y squared, and then we tack on that dy dx, plus 3 equals, and the derivative of 6,
Jesus Christ.
0. So we take the derivative of everything, right? Take the derivative of everything. Now to find our actual derivative, to find what it is, our derivative is dy dx, or y prime, right? That's what, every other time when we've written a derivative, we've said y prime equals, and then we have something over here, right?
Yeah.
So we need y prime to be all by itself. So all we do is we just start moving things over to the other side to get y prime by itself. So we subtract 2x and subtract 3. Is negative 2x minus 3. And then I want to get dy dx by itself. I just divide both sides by negative 6y squared. So my dy
Not simplifying.
dx is this.
I'm not
I am not simplifying that.
And you could see that these are all negative, so they could all become positive. So, I mean, that's like the extent of your simplification if you want, but. Yeah? Makes sense? Okay, so let's find the slope of the lines tangent to and normal to the graph of that. So this is a circle, right? This is, or, well, this wouldn't be a circle because of that 4, but it'd be an ellipse or something. It'd be something. Maybe it'd be something. We're trying to find the slope of the tangent line at that point. So that means we got to find the derivative. So we first find the derivative of this function. 2x plus 8y dy dx equals 0. Does everyone agree with me there so far?
Yeah.
Okay. Now I got to get dy dx all by itself because that's really my derivative is dy dx. That's what I want. So I get that all by itself. So I have 8y equals negative 2x. Oh, that's dy dx still.
Let me go see how much more complicated
The complication that comes usually is when we have to use like the chain rule or something inside of something. Okay, so this
How do you
says
get rid of it? Use divide.
No, I was going to say I should get rid of the 25, but we have to differentiate that.
I have to differentiate everything. So this is my derivative. So the slope of my tangent line, I'm going to plug in x and y at that point, right? I just plug x and y into this function. So I have negative 3 over 4 times 2. So negative 3/8 is the slope of my tangent line. And then we want the slope of our normal line. You guys remember what the normal slope is?
1, 4.
So your normal line is the one that is the perpendicular to your tangent line. So, yep, 8. And that's it. Okay, you want to try another one? Should we go harder? Yeah, more hard problems. That's what you said. Okay. We have this. We want to find the derivative and evaluate at that point. We want to find the slope at that point. We had to. Okay. So first we find the derivative of this term, which is 3x squared. Then we need to find the derivative of this term, which is going to be a little challenge, so I'm just going to leave that blank there. Find the derivative of this term, which is 3y squared dy dx. And then the derivative of this term is just 5. So I did all the easy ones, and now I just got to do that one in the middle. And it's not easy because we need a product rule.
Oh, man.
Are you serious?
Oh, my gosh.
So,
Why did they just make it so you could find the code?
so f of x would be negative 2x, and and g of x would be y. Do you agree with me there?
Wouldn't it just be 2?
Yes, so the derivative would be -2,
Oh.
and the derivative of this one would be just dy dx. Okay? So, to find the derivative of this actual term, I'm going to do fig plus gif. So -2y plus -2x, we're just gonna recognize that that's minus 2x dy dx. So I use the product rule to get here. Then I put that one back in here, right? I put that in the middle, right? And now, so my real function, I'm at 3x squared minus 2y minus 2x dy dx plus 3y squared dy dx equals 5. How do I get dy dx by itself? Let's get everything that doesn't have dy dx on one side, okay? So I'm going to leave these ones on this side. And then I'm going to move everything else over. So -3x squared plus 2y.
We don't have to simplify, right?
You don't have to simplify, but you do need dy dx by itself. So then we divide this whole thing. Oh wait, I'm skipping a step. Then you factor dy dx out, and you have -2x plus 3y squared equals this whole thing. And then you divide the entire thing. And dy dx equals that. Does that make some sense? Okay, there's one more thing though it says. Evaluate at the point 1, 2. So evaluate when x equals 1 and y equals 2. So I have -3, I'll write it nicer, I can't. So we just plug in x equals 1 and y equals 2 in here. And we get -3 plus 4 plus 5 over -2
You just plug in 1 and 2.
plus 12.
The equation is like,
So it's 9
how you did that?
over 10.
Why is the
No.
3y on bottom? Why would you divide it if you're adding it?
Or can you take
But
out the
it's
dy
multiplied
dx?
times the dy dx.
2x.
5 -3.
That's on the bottom, so that's right.
There's 2 of them,
6.
Nate.
What?
Every time you derive the y, there's a dy dx.
That's stupid.
Yeah, so there was one from this term, and then there was one from the product rule of in this term. That's where our dy dx's came from.
This is a positive, right?
Yeah, so you should have, when you evaluate, you should come up with 3/5. Are we on the bus? Maybe fell off the bus.
No, I fell behind that.
Okay, you might have,
Never got on.
I don't know if we have time for this last one.
But I'm just gonna be behind it.
I know. Okay, let's look really quick, see what we can get done. Circle. Since circle, we want to differentiate. We have 2x plus 2y, and you could write y prime. I just lose my y prime, so that's why I don't write it as y prime. The number 4.
This got a y.
It took up all my room.
Why?
That's
What was
problem.
the answer to 3?
3/5.
3/5. Oh yeah, I got that.
So this is my first derivative. I get y prime all by itself. So I have 2y, y prime equals negative 2x. Y prime equals negative x over y. And let's stop there anyway, because we'll find the second derivative tomorrow.
So we don't need to do this for homework?
Well, I would look at it if I were you and get kind of an idea of what you know and what you don't know, but you don't have to.